Alright, hello again. This is Jeff Scott, your instructor for 152-145 Advanced Java Programming for the Fall 2015 semester. I'm coming to you from my kitchen, so if you hear sound in the background, the washer's just finishing up its cycle. Hopefully that'll be done soon. But I wanted to get going because I don't know how much time I'll have to do what it is I'd like to do, and that is to go over the slides that make up the presentation for Chapter 11, which is GUI Applications Part 1. As you can see here, here's our topics. Again, I don't want to read to you, but it's being able to use the GUI controls, which we have not at all used so far with Java. Many Java apps use a GUI interface. As GUI as we've gotten so far has been to use the input dialog or the show message dialog. That's been about it. All right. But we want to create GUIs, as it says, or we want to be able to accept input from the keyboard, from the mouse. We want to put our components in there, so we want to be able to create something, maybe not this, but something that utilizes a lot of different controls, or typically called widgets in Java speak, and the ones that are shown here. Now notice, as it says, Java programmers use JFC or the Java Foundation classes to create GUI apps. Alright, it says the JFC consists of several sets of classes, not many, but probably most of which are beyond the scope of this book. The ones that we'll concentrate on are AWT and Swing. AWT is an acronym for Abstract Window Toolkit. It's the way that GUI used to be done in Java. Alright, now many of the things that you do with GUIs, you still have to use the AWT, but the idea behind the Swing classes is twofold. First of all, unlike the AWT, the Swing classes are meant to be more lightweight, so they're not as resource intensive. All right, so that's the first thing. And the second thing is Java's mantra is write once, run anywhere, WORA. But the problem is, with GUI controls, they look very different typically, especially the Abstract Window Toolkit controls look very different on a Mac as opposed to on an Intel machine, etc. So the idea with Swing is the stuff would look more similar on any kind of platform. So you can read this yourselves, okay? As it says, Java programs using the AWT look consistent with other apps on the same system. All right, but the behavior can differ across different kinds of operating systems. Again, these AWT components are typically called heavyweight components, as opposed to Swing. Now, Java, I believe, is I don't know what it's on, even like Java 8 or something like that. So Swing has been around for a long time. As mentioned here, it's a library of classes that provide an alternative for creating GUIs. Very few Swing classes rely on pure classes, so they're more lightweight than the AWT is. They draw most of their own components, so they have a more consistent look and feel. Good or bad, but just so you know, for instance, if I want to be able to create a button and I want to use the AWT, it's part of the button class. If I want to create a Swing, that's an AWT button. If I want to create a Swing button, it's J button. So virtually they're the same types of controls, whether they're in their AWT or Swing, but with Swing, they have a J at the beginning of them. Notice too, when you use the Swing classes, you put import javax, that X must be there, .swing, .star. If you use the AWT, it's java.awt.star, no X. Most of the time you are going to include both of these in order to be able to do whatever it is you want to do. All right. It says their programs that operate in a GUI environment must be event-driven. So in other words, the system is sitting there waiting for you to do something. You have to hook up and write an event listener. As it says there, it's an object that automatically executes when some event occurs, such as a button being clicked, for example. Now they talk about dialog boxes. I'm not going to get into these because we've already been working with a message dialog. We've already worked with the input dialog, and we can take a look if they have an example here of the confirm dialog. All right, so there's a confirm. They're all parts of the J option pane class. So we've done a lot of work with these two. JOptionPane.showMessageDialog is mentioned here as used to display a message dialog, and there are several ways that it can be done. So when they talk about the overloaded versions, that's what they're talking about. Now, whenever we've done this in the past, when we've done a show message dialog, we've always put null there for our first parameter, and then whatever we want to show. Notice it says the first argument can be a reference to a graphical component. The dialog box will be displayed inside of that component. If null is passed, it just puts it in a box. The second is the message to be displayed. So we'll start to see more stuff, so to speak. So if you look here, it says by default the dialog message box has a string displayed in its title bar, the word with the word message on it. All right, an information icon with an I, but you can change that. Now this is not that different than some of the stuff that we've looked at in the C# class. So notice what we have here. We still have null, invalid data. All right, so that's the message that produces. My message box, so that's the title. JOptionPane.error message, so instead of it being an information icon, it's now the stop sign, or basically the error type of button, or the type of message. And you can use error, you can use information, which those are the two we've seen. Warning, which is I think is an exclamation point. Question, which is just that. And plain message, where I think it has no icon whatsoever. And there's your examples. And you might say, well, why didn't we go over this stuff earlier? Really and truly, the stuff that we went over more than met our needs. At least in my opinion, it did. All right. So, dialog boxes, as said, are displayed by the J option class. They're modal dialog boxes. So when you've got a dialog box, if any one of these here displays until you click the OK button, basically they don't go off the screen. They're modal. They're waiting for you to come in and respond to them. As it says, there, a modal dialog box suspends execution of other statements until the dialog is closed. Input dialogs, a quick and simple way to ask the user a question. We've already gone over this. We've been using this. It comes with an OK button and a cancel button. If you press OK, the dialog returns the user input. If you press cancel, the dialog returns null. So you can check for that to see if they pressed OK or cancel. They show a couple of examples right here, but this is the kind we've used, as Doug Tabbitt would say, ad nauseum. So we've gone through a bunch of these. So the argument that's passed is the message to display. Enter your name. If the user clicks the OK button, then whatever you enter for the name is put in the name. If you click on the cancel button, null is what's sent to name. So you could check whether or not it would be null. Again, notice what it says here. By default, it has the word input and it's got a question mark there, but you can change it, just like we looked at with the message dialog just a minute ago. So notice here we've got enter the value again, enter carefully, so we changed the title, warning message, so we've changed the icon. Same kind of icons that we talked about previously. All right, and the confirm, typically that's a yes, no, and a cancel. All right. So again, it's going to either send yes. If you click that button, value is set to yes. If you click that button, value is set to no. If you click that button, value is set to null. The show confirm dialog, as it says, returns an integer that represents which button was clicked. So you can code for that if you want to or need to. Here's some examples. So they've got an example in here, and we'll go over that when we go over the actual textual material in just a bit. Notice that if you want to, you can use a fourth parameter in here. Yes, no, which has just these two, and yes, no, cancel, which would have 3 of them. As it says, a GUI program does not automatically stop executing when the end of main is reached. Swing generates a thread, and the reason that that's important is it means that you can have multiple things running at once in multiple threads. So if system.exit is not called, the thread continues to execute. Typically when you do a system.exit, and we've talked about this in earlier classes, you say system.exit, you've got a 0 in parens. That 0 traditionally indicates success or a normal termination. All right. Often, as it says, apps need one or more windows for various components. A window is a container. A container that can be displayed as a window is a frame. Using Swing, you can create a JFrame. Now we're starting to move more towards the GUI stuff we have not covered yet. A frame basically is a window with a border around it, a title bar, and buttons for minimizing, maximizing, and closing the windows. Also referred to as the window decorations. So if we created a simple window, that's what it would look like. And it would be our responsibility to set up the height and the width of the window. By default, and we can also set up whatever it shows here for the title, but minimize, maximize, and quit. That's the kind of code that we'd use to set up the height and set up the width. If we're using just Swing here, we'd have to import javax.swing.star. When you do this, you need, as mentioned there, to create an instance of the JFrame class. So basically doing this, and there's a few more things that you have to add, but doing this is what you need to create this. But you have to make sure you set the width and the height as well. All right? So as it says there, when you have a statement like this, it creates a JFrame object in memory and assigns it to the address of the window variable. The string that is passed to the constructor will appear in the title bar. You've already seen all this. By default, the JFrame is invisible. You can set the size of the window like this. Now you don't have to do it this way with window width and window height, because if you remember, we previously set the window width and the window height. Usually you use constants like this as opposed to coming in here and putting in 350 and putting in 250 there. This is a very important line right here where it says jframe.exit on close. That says when you click the close button, so when you click that X, close, stop the app from running. All right. And as it says there, it takes an int argument which specifies the action. You can hide it, okay, but most of the time this is the line that you're going to put in here. Notice when we set visible to true, all right, it's a method that takes a Boolean argument to either display or to hide a window. Usually it says we use inheritance to create a new class that extends the JFrame class. You're going to see all this in a little bit when we start to go over the stuff that's in the book. It says when a new class extends an existing class, it inherits. We talked about inheritance. The members act as if they were written into the new class declaration. We talked about that before. And then you can add whatever you want for specialization. All right. So, as mentioned, Swing provides numerous components that can be added to a window. You'll notice these are all Swing components. If we were using AWT components, they would be label, text field, and button. Since they're all swing components, they're J label, J text field, and J button. We all know what labels and text fields are. Text field is like a text box that we've used in other languages, single line of input, and a button's a button. So the first real program I believe that they have you create in this chapter is the one shown right here. So you create a window. The window has this title on it. It has a box there to end it. It's got a label here. It's got a text field here. And it's got a button right there. So notice when we start creating these, private J label message label, private text field or J text field kilo text field, private J button calc button, and then message label equals new J label, enter a distance in kilometers. Well, that's this. The kilobyte, that's just the size of the field, and calc button equals new J button calculate, so that's the name that's going to be on the button. As it says, the code that you see up above both declares and instantiates 3 different swing components, sometimes known in Java-EE as widgets. All right, a content pane is a container that's part of every JFrame object. So a window holds a frame, and a frame holds a content pane. Every component you add to a frame must be added to its content pane. You do this with the class's add method. Notice the content pane is not visible and it doesn't have a border. It's a container. It's an invisible container for lack of something better. Panels cannot be displayed by themselves. They're typically used to hold and organized sets of related components. You create panels, as it says there, using the JPanel class. So here we're creating a new panel. It's called panel. And we're adding to it that message label, that text field, and the calculation button. Components are typically placed on a panel, and the panel is added to the frame's content pane. Again, we'll look at examples of all these. But if we have this, the idea is when we click the calculate button, we want to check what's in here. If it's not going to be numeric, and we either have to put it in a try-catch block and check for a number format exception, all right, or we have to use an if statement, or we just, to check to see whether or not it was non-numeric, or we just have to trust our end user that they'll put a number in there. But the idea is you put a number in there, you click that button, and you're going to get something like a message box or something like that that's going to show you the answer. So if I put 100 in there, 100 kilometers, and I click calculate, it'll tell me the equivalent of miles in some kind of an alert type of box. So again, we will look at all of this code when we get to the regular chapter in a bit. All right, I don't know what more to say about events than this. Java is an event-driven language, as are most languages that we've worked with this semester. When an event takes place, the component responsible for the event creates an event object, which has information about the event. As it says, the component that generated the event object is the event source. We set up an event listener as an object to respond to the event. So we have to make sure that we code the click event so that if the user does click a button, that our code reacts appropriately. As mentioned, the source component fires an event which is passed to a method in the event listener. Event listener classes are specific to each application. And event listener classes are typically written as private inner classes. And if you don't know what those are, you're going to see them in this chapter. So in other words, we've got a class, and inside of our class, which they call outer, you have another class. You don't have to do it that way, but that's the more standard way of doing it. Every event listener class that we create must implement an interface. All right, we've talked about interfaces in a previous chapter. When you write a class that implements an interface, you're agreeing that the class will have all those methods that are specified in it. All right? And again, we're going to get into all this stuff in just a bit. JButton requires an action listener class. So it must implement the action listener interface, and it must have a method that's called action performed. Notice that's the code to be executed when the button is pressed. So it's not a click event like we've been using in other languages. All right, and also remember, we have to code this. Okay, we have to create it. We have to create it in code and then handle it in code. That's what they're showing right here. The process of connecting an event listener, as it says, is called registering the event listener. All right. So you have to create the event listener, then you have to register it. Notice, and here's a key point right here. Again, you'll see this when we go over it in just a bit. When the user clicks on the source button in the action listener object's action perform method will be executed. As we mentioned before, we want to be able to put a value into there where what we looked at earlier, where it asks for the number of kilometers. When we click the button, we want that value to be converted into miles or whatever the heck it is we want to convert it to. Many Swing components have a background and a foreground color that you can use if you want to or need to make things stand out. Java has, I believe it's 13 built-in colors. You can see them right there. I'm not going to read any of them to you. It is possible to use some red, green, blue, but more often than not, you're just going to use the ones that are shown here. Not that you have to, but it's a lot of work to do it the other way. As mentioned there, event objects contain certain information about the event, which you can obtain from calling one of the event object's methods. There's getSource and there's getAction command. All right, I believe we looked a little bit at these last semester, but we're going to look at them some more, I think, in here. GetSource returns a reference to the object that generated the event. GetAction command returns the action command for the event. It says they're equipping GUI classes with a main method. Well, remember, Java applications, not an applet, which we'll talk about in a few chapters, but Java applications always start execution with a main method. So we'll go over that example among others a little bit later. When you design a Java app, it's important that you understand what a layout manager is. And what a layout manager does, as mentioned in that last bullet, is it controls the positions and sizes of your components, and it adjusts them if or as necessary. Java provides several layout managers. They're not all shown right here. There's a flow layout that goes from left to right, all right, and that's the default. There's a border layout, which has the north region on the top, the south region on the bottom, the west region on the left, the east region on the right, and whatever's left in the middle is called the center region. All right, and there's a grid layout that arranges components in a grid of rows and columns where they each must be the same size. So if I decided I wanted to have a border layout, I would do something like this, or I do something like this. And again, you're going to see plenty of these. The FlowLayout Manager literally means lay stuff out horizontally from left to right in the order in which you added it. When there's no more room in the current row, start a new row. The FlowLayout Manager is kind of nice because it allows you to be able to set stuff up on your screen. Again, center, left, right, etc. You can also do some work there with gaps, and for lack of better words, using a gap in there is somewhat like using a margin or padding for CSS. Not the same thing, but very similar in nature to the idea. This is the Border Layout Manager. All right, so the top is the center, the left is the west region, the right is the east region, The bottom is the south region, and everything else is the center region. Now, I believe you need to have a center region, but you don't even need any of the other ones. So maybe I've got a north region on top for a title, and maybe I've got an east region over here for something, but I don't have a south region and I don't have a west region. Well, what happens is when you're doing something like this, the center is greedy. So if I don't have a west region here, the center comes and it grabs all that room. All right? If I had an east region and I didn't have a south, that east part would grab that little area that's right in here, but all the other area that's in here would be grabbed by the center. Because as mentioned, it's greedy. This is how you position things in those different panels: north, south, east, west, and center. Now that, I'm not going to disagree with what the author says right there. It says each region can hold only one component at a time. That's true. But what gets put inside of any one of these can be another panel. So in other words, I could set something up in here where I had a panel layout, a flow layout maybe, and I put a whole bunch of stuff in it. All right, again, you're going to see examples of that as we go on. As mentioned, and we talked about this in other classes, normally the size of a button is just large enough to accommodate its corresponding text. The buttons displayed in a layout region will not retain their normal size. They will, by default, they will take up that entire space in that region. We'll see examples of that. If the user resizes the window, the size of the components changes automatically. By default, there's no gap between the regions, so you'd have pretty ugly, so you'd probably want to add some of your own gap. Again, this is just like with any other language that we've dealt with, in that to get it to look the way you want it to look takes some tweaking. Okay? As it says, if you want to add components to panels and then nest the panels, that's what I mentioned to you before. Okay? The grid layout kind of looks like a spreadsheet. And the way that the grid layout sizes itself is it looks for the biggest, so if you can imagine, we've got what, a 5 by 5 grid here. So 5, 10, 15, 20, 25 components. Out of these 25, it finds the biggest. So let's say we had images and a bunch of other stuff in here, and let's say that one was the biggest. If that one is the biggest, it goes and resizes the other 24 so it's the same size as this one. All right, so the cells have to always be exactly equal in size. As it says there, each cell can hold only one component. All cells are the size of the largest component. All right, a component placed in a cell is automatically resized to take up any extra space that it might need. So setting this up in a way is kind of like setting up a text box, because you put the number of rows and the number of columns in it. Radio buttons we've talked about before. They're very similar to radio buttons in other languages. As mentioned right here, they allow you to select one from several possible options. If you set this up, there's a Boolean you can put on here. So for instance, this would just show a radio button and it would say choice 1 with a button. This would be a radio button with choice 1 and the radio button would be selected. I don't know if they show it. No, I guess I thought maybe they'd show it on the next page, but they don't. Radio buttons typically are put together in a group. The group, all right, so you create all the buttons and you put them in a group. The group, again, only one may be selected at a time, and when you select one, it automatically deselects any other one that might be open. Again, an instance of the radio button group, or the button group class, is used to group radio buttons. So this is how you set it up. Create 3 radio buttons. That one will be checked or circled by default. You stick them inside of a radio button group. All right. And then you add the radio buttons to that group. As it says there, if you wish to add the radio buttons to a panel or to a content frame as opposed to a group, you must add them individually. Another reason for not doing it that way. Radio buttons, as it says, you must write an action listener class to respond to a radio button event. The radio button class is selected method returns a Boolean. So it returns true if the radio button is selected and false if it is not. So that's the kind of code that you'd write. If name of radio button dot is selected. By using this do click that they mention here, and I think they'll mention it again later, that forces, all right, so that forces a radio button to be selected. Not done often, but if there's a reason that you had to force something, you could use the do click. Checkboxes are like radio buttons, except they're very similar in many ways, but where radio buttons are mutually exclusive, checkboxes are not. All right, so you can select them or deselect them at runtime, but you can select as many as you want at one time. As it says, they're often displayed in groups, but they're not usually grouped in a button group because there's really no reason to do that. There's two different checkbox constructors. The difference between these two, again, is in the second example, if you say Boolean selected, that box will automatically be checked. When a checkbox is selected or deselected, it generates an item event. So you have to write an item listener class, which must implement the item listener interface, and it must have at least one method, and that method must be item state changed. So here's the kind of the way you do it. You create the object of the class, you register the item listener object. The item state change method is automatically run then whenever you check it. The is selected determines whether or not the checkbox is indeed checked. Just like we talked about the do click that you could use with a radio button, you can do the same thing if you want to or need to with a checkbox. All right. They talk about putting borders around here. This is a lot like a group box that we've looked at in .NET, where you can categorize stuff. It sometimes makes it a little easier to work with that way, just by adding some borders. All right. As it says, the set border is used to add a border to a component. It accepts a border object as its argument. And there is a border class, border factory class, part of the javax.swing package, as it says, that has static methods that return various type of borders, curved borders, etc. And some of the ones are shown right here on the slide. The chapter ends with, and I think we're going to spend quite a bit of time, what I'll probably spend most of the time on, not in class, but in the lecture part of that I do in here, because not the lecture on the PowerPoints, but the chapter lectures, will go over this Brandy's Bagel application. And if you notice, this has got more classes than any assignment we've ever had before. 1, 2, 3, 4, 5, 6 classes. So it's a complex app that's going to have a lot in it. In addition, it'll have a splash screen, so they'll have a little picture of Brandy's Bagels when it starts up. All right, the last thing the author mentions in here on this slide is another way that you can do some debugging is to have kind of system.out.println statements. And that's it for the chapter. All right, so I'm going to come back in just a minute, and I'm going to go over Chapter 12, which is GUI Applications Part 2.